minutes. You get me exclusively for the next 15 minutes. So when you're done with 3, you're going to go to 6. This look should be pretty good.
Yeah, it's good.
Let's see what it is. So it's creating geospatial data. So you're gonna go and you're gonna get the chapter 6 data, and it's gonna be a shapefile. Oh, so it's an Excel spreadsheet. You're gonna probably join that to that shapefile, or something like that. Oh, you're gonna create a file geodatabase. So you do that inside of our catalog. Convert a table of coordinates to a point layer. Create feature classes within a geodatabase. This was chapter 12 and 11, 12, and 13 of your 150 book. This is exact. You're not going to do any digitizing, so actually remember that. If it tells you to do digitizing, don't do it. How to set a bookmark, you should know how to do a bookmark. Digitize. You're not doing any digitizing. How to measure lengths, you should be able to know how to do that. So you're going to look at Youngstown State. The guy who wrote the book teaches at Youngstown State. That's why all the data is in Ohio. Okay, one big thing that will help you that it doesn't tell you, take this Excel spreadsheet, convert it to a Excel 97 to 2003. Do you know how to do that? Okay. Yeah, we got 10 minutes, so I can show you how to do that. Do you have your data's here?
Yes.
Open up Excel. That'd be the easiest way to do it. And file open. Now the reason that we're going to do this right here, this extension XLSX, that is an Excel 2010 file type. ArcGIS does not like that file type. Sometimes it works, sometimes it doesn't. That's why anytime you have an Excel spreadsheet, you should always down convert it to and I'll show you, a 97-2003. And a 97-2003, that is going to be just XLS. So open up File, open. You're already up there. Up. One, no, down one. No, open. Click Computer. In Browse. Okay, your drive is D. Double click that. Go to I don't know what that is. Hit the back key. Are you sure that is that?
Yes.
Double click it. You're missing. Oh, GP150 data.
Yes.
Okay, go to chapter 6. double click that.
Oh, that's it.
All right, so right now it's in this format. Go File, Save As, Browse. Okay, it's in the same spot. So pull this Save As Type, pull that down. See that Excel 97 to 2003? Select that. Now up here, call it parking coordinates underscore. Oh, hold on. Underscore. Use this one. To spell it right out, use this one. And then click Save. And then X out of here. X. Okay, so now when you go through there, don't use this one. Use parking coordinates underscore, use this one. It'll make your life easier.
Thank you so much.
And you got 7 minutes if you got more questions. Any last minute 150 questions? Shoot them out. And Joe, you know you're free to stay here while I teach the other class to do your stuff. This is almost like the old days when I would have a class of 25 and only 2 people would show up for weeks and weeks and weeks.
Excuse me.
Yep.
I tried to find out how to actually use for I tried this one test.
Mhm.
Now for this one I'm supposed to use, it's right here.
Double click it. Oh, that just opens it.
Yeah.
Unless it tells you to bring it in to
Yeah.
use the plus button.
Ah, okay. Right.
There you go.
Thanks.
Mhm. All right, I'll get started on my little introduction. I'll start in on chapter 6, probably about 5 o'clock when a bunch of people show up. So today's on chapter 6, working with coordinate systems and projections. I could spend 6 hours explaining these 11 pages, the first 11 pages of this chapter. This is one of the most complicated things to grasp as it relates to GIS, coordinate systems, and projections. So the objectives in this chapter: become familiar with geographic coordinate systems, projected coordinate systems, know the difference between both of those. And since I do have limited time, I'll be giving you some things that you should be studying for the midterm. The 1, 2, 3, 4 of you that are here. Okay, so the way to think of a coordinate system is an XY location. It's 2D. I mean, everything on here, just say this was the x-axis, this is the y-axis. You know, normal coordinate system. However, when you're dealing with geography, with GIS, you're dealing with the world. The world is not flat. However, there's a couple extremist groups that did say the world is still flat. It wasn't Trump, was it? No. So what you have to do is you have to project the 3D world into a 2D world. That's called a projection. The way to think of this, the easiest way to think of it, as you have an orange. You have to describe the X, someone asks you to describe the XY location on that orange, but you can't do it because the orange it's round, it's got depth to it. So what you have to do is you have to define a projection which takes that 3D orange and puts it into a 2D space that where you can give it an X and a Y location. So that's coordinate systems. All right, you should know what latitude and longitude is. The prime meridian, which is in Greenwich, England. The equator, I believe that's latitude. Longitude is this way, latitude is this way. If I tell you to show me where the equator is, where the prime meridian is, you should be able to know that, or tell that. That's on page 150. I'm just going to go right down 154. It tells you latitude and longitude. Shows you some pictures. Latitude and longitude is, I'm not going to give you this, but Latitude and longitude is in degrees, minutes, seconds is the way that you describe that. That is also called WGS 84 if you were doing projections. And they go in between difference between a sphere and a spheroid. You don't have to know that for this class, and you'll never remember it anyway. The big thing is remember that your projection is taking that 3D and bringing it into a 2D surface. Think of the orange. You peel the orange, and it comes out into a 2D surface. And there's plenty of different ways you can peel the orange. Conical, azimuthal, as a muthal, whatever. Cylindrical, secant. This gets very, very complicated, very, very quick, and it's all trig. If you're not good with trig, projections are bad. So a good way, page 159, the Mercator projection, which is a standard projection. So looking at that first image on 159, that is the Earth in a 2D space. So there's an X and a Y coordinate attached to everything on that Earth. However, the Earth is not in 2D. So that is just a type of projection. The underneath that, the World-Winkel triple projection. And there are hundreds of thousands of different projections out there. No one has ever settled on one, and it makes life extremely miserable. However, good for you, good for everybody else, ESRI does projections. It knows what the projection your data is in, and you can add all kinds of different data, and it will project it to whatever you want it to be. So it does it for you, the map or the program.
I'm sorry.
Yeah.
We're on page 260.
I was just explaining 159, but it's was it one from 153, 159.
So we need to know trig.
No, we're dumbing this thing down. You need to know. Yeah, I could confuse you, and it would take a couple weeks to actually do this justice to really explain projections. All you have to know is think of the orange, you peel the orange, you get a 3D surface, you need to make it into a 2D surface. To do that, you create a projection. There are thousands of different types of projections based on looking at page 157, cylindrical, conic, transverse cylindrical, all these different geometric shapes, you can make projections.
So this is just chapter 6, and this is just explaining it.
I'm
right?
just explaining projections.
Okay, and then what we do we still follow the same rules when we do the homework, right?
Yeah, I haven't even got to the homework yet.
Oh,
I'm trying to explain a little
Gotcha.
bit about projections in 5 minutes.
Okay.
Instead of 5 hours. So looking at, there's different types, as 159, the World-Winkel triple, the good homolocene projection, page 160, which sort of looks like a heart, the World-Bond equal area projection. Again, there are hundreds of thousands of projections. Erie County, we use something called NAD 83. The Water Authority, Erie County, almost everybody uses NAD 83 as the projection around here, except the state DOT. The state DOT has to be difficult. They use a projection called UTM Zone 17, which isn't close to NAD 83. But that's okay because ArcMap will change this for you so you don't have to do it. You used to have to do it by hand, which is horrible. And it talks a little bit on page 160, projecting data in ArcMap. It shows you where we're going to show where you change that. It goes into a little bit about UTM, state plane. You don't have to know anything about easting and northing. On the fly projection, that's what ArcMap does for you. It converts the projection as you put it into ArcMap, so you don't have to. You don't need to know that. Don't need to know that. You're lucky you're not at UB because we would have done trig when to explain this. All right, so today, chapter 6. This will be really the last easy assignment of the semester. If you thought the other ones were hard, they get a lot harder. This will be an easy one. So this one, you're going to do a one-page summary of everything that we've done and also the important things on those first 11 pages of the chapter. Make sure it's one page, 25 points. For the half the class that's not here, we're going to have screenshots that's not included in the assignment. For 6A, there's going to be screenshots and MXDs for 6B and 6C. We are not going to do 6D. And I didn't change this from last time, so I even mentioned, since this is a new book, I used the same assignment sheet for last semester. Maybe I'll change that.
Everything's the same, or you're going to change it?
I'm going to tell you what your deliverables are. They're not in the assignment sheet right now.
Gotcha. Okay.
Like an email or something?
You're
Or
here.
Blackboard in here? Okay.
Yeah.
You say that again.
Say it again. One-page summary. There's going to be the MXDs are going to be from B and C. You're going to submit those, and then I'm going to tell you what screenshots from A, B, and C that need to be added for your stuff. And maybe I'll change this to give the people that didn't show up an opportunity to turn in something correct. All right, so 6A, examining coordinate system. So we're going to take a look at a piece of data, and we're going to look at the coordinate system associated with it. All right, switch to this one. Okay, the first thing it says is start our catalog. Remember, put your mouse in the upper right-hand corner, go down, click search, start typing our catalog, and it will open up. And here is what our catalog looks like. Just make sure. All right, I'm in our catalog on this. Now you want to connect. When you do this the first time, you're not connecting to your data. You have to tell the program where your data is located. So that's always the folder plus. And remember, you want everything on your desktop. You want to go to the S drive and take the chapter 6 data and put it on your desktop. So there's my chapter 6 data. The folder. So that was step 1. Open up our catalog, map to chapter 6, go into the chapter 2. The book says C, ESRI Press, GTK, ArcGIS, but it's going to be where your data is located, and your data should be on the desktop. So step 2, click usstates.layer. So in this chapter 6, under data, there's going to be a usstates.lyr or layer file. And it tells you in the darker greenish, if you don't see the file extension on the menu bar, click Customize our catalog options and clear the Hide File Extension checkbox so you can see the .lyr. Then once you've highlighted it, they want you to hit the Preview tab. And now the screen looks like what I have on page 165. So that layer file, and actually a layer file doesn't contain any data. It doesn't contain the spatial component of US states. All it does is it sets it up so it tells what the data should look like, what color it should be, the size of the lines, the thickness. So when you see a layer file just does all the different coloring and line weights for you. So that was that. Step 3, click the preview arrow. So down here at the bottom of the screen, right now you're in geography. You want to go to table. And it shows table has 2000, 2010 pop figures for each state. So if you scroll, there's pop 2010, pop 2000. And even though we're not doing the blue questions, how is pop change attribute calculated? It's pop 2010 minus pop 2000 divided by pop 2010. Now, hint, it involves 2 attributes in a simple math formula. So step 4 in the catalog tree. So this is the catalog tree. Right-click usstates.shape. And go to properties, which is at the bottom. So this shapefile properties window pops up with a bunch of different tabs: general, XY coordinates, fields, indexes, etc. Click the XY coordinate system. Now notice when you do that, just take a look at all the different coordinate systems that are out there. I mean, each continent has their own coordinate system, each country has their own coordinate system, each state has their own coordinate system. But this one already tells you that because it highlighted it, it's a NAD 83, which is just the one that most people use is NAD 83.
So it's like a universal way of, if everyone's on the same page for using coordinate systems, because some countries may say you're really at this coordinate while some.
Well, some things may chop up that orange in a whole different direction,
Okay.
and you don't, your XY, your 0, 0 might be in the upper right on that different country orange.
Yeah. What does the military use?
Typically WGS 84, which is lat long, but they can use it anything. All right, so this is NAD 83. And what are the blue questions? What are the angular units of this coordinate system? That's actually something that I may ask you. So you go to our catalog, you go to what is the angular units of US states? Go to the properties. You would go to the XY coordinate system tab and notice angular unit is a degree. If I ask what's the prime meridian, it's Greenwich. What's the datum? D North American 1983. What spheroid is it? It's GRS 1080. So if I ask you questions, you go into the table, into the different items to pull out the information. So that's what are the angular units, what is listed as the prime meridian. These are blue questions. All right, step 5, click cancel to shut it down. In the catalog tree, double click cities.shape. So same thing, cities.shape is WGS 1984. The other one was NAD 83. This is WGS 84. WGS 1984 is lat long. What spheroid does this layer use? You just go down, spheroid WGS 1984, if I were to ask you something like that. Step 6, click cancel. Open the properties for lat long. This is in NAD 83. Click cancel. Open up Canada. Looks like we're going to open up all of them. Canada, Mexico. Canada, Mexico doesn't have a coordinate system. In this class, you're not going to worry about that. In the next class, if you take it, then it becomes interesting. All right, so notice there's nothing there. Most of the time, the reason there's nothing there is because the person that created it didn't add it. bad on them. All right, so step 8, in the Canada-Mexico shapefile properties dialog box, on the XY coordinate system tab, click the add coordinate, which is, so in the upper right, a little pull down, put your mouse over, it says add coordinates. Click that and click import. So what we're going to do is we're going to assign a projection. Right now it has nothing. We're going to give it a projection from another shapefile. So we're going to import. And we want to browse to, we're going to give it the projection of US states. So I need to find my chapter 6, data, US states. And it knows automatically GCS North American 1983, which is MAD 83. I did step 8, step 9, click OK. Oh, that's it. What did I want you to do for? Oh, screenshots from 6A. All right, so the screenshot that I'm looking for, Canada, Mexico, it should be this. You should see favorites and GCS North America 1983. That's all I'm looking for part A, for 6. So basically it's the screenshot on page 170, but then you do step 8, and once you do step 8, it'll put it in there, then take a screenshot of that. All right, any questions? 6A? Yeah, save it for after. Okay. So one screenshot. 6B. All right, for this 6B and C, you're going to be submitting MXDs, and then I'm going to give you some screenshots. So we need to open DX06B. First thing I need to do is switch to different scene. Open chapter 6, 6B.
We close out our catalog, right?
Yes, we're not. I don't believe we're using it again. All right, so now we open up this MXD. Notice there's nothing in there. Notice there are 3 data frames: Alaska, mainland states, and Hawaii. There's no red exclamation points because there's nothing there. And we're going to add data into each one of these data frames. So step 2, page 174, add US states.layer, not the shapefile. You're going to add the layer file to the mainland states data frame. So you click on mainland states, hit the plus, and US states.layer. There's 15 different ways you can do this. You also could have opened up our catalog. Oops. And of course I got rid of it. On the right-hand side, gone to your folder, and then dragged it over if you wanted to. But I like doing with the plus. Okay, step 3, add Canada-Mexico layer to the mainland states. So I hit the plus, Canada-Mexico layer. Ooh, and I get a red exclamation point. This is good. Yeah.
So what was the first data layer that you added?
US states.
You didn't add the whole chapter 6 data?
No, just one at a time. So the second one was adding Canada, Mexico. I get the red exclamation point. So I double click that because I have to point the data. It didn't find it. So look at this. In my specific MXD, Canada, Mexico, it might be pointing good for you, but mine is pointing to the D drive, Dropbox, 2000, someplace where it's not. So to change that, set data source, chapter 6, data, Canada, Mexico. This is where it's pointing to a shapefile. The layer file points to a shapefile. Add, click OK. Now it comes in. Did anyone else get the red exclamation point?
Yeah, I did.
You did? Where was it pointing? Something weird, strange?
I mean, I was able to fix it, I think, just now by doing what you guys did.
Yeah.
Do it again? Okay, so
But now, Canada, Mexico should just be like a gray outline, right?
Yeah.
Okay.
Okay, so you're going to add U.S. states to the mainland states data frame. So to add data, you always hit the plus button. You hit the plus button. Now you need to tell the program where your data is located. Your data should be on the desktop. Mine isn't on the desktop, but we'll pretend that it is. So chapter 6, data, US states. I'm adding the layer file. I'm adding the layer file so it knows that everything should be in this green color. And it should look like that. So then I want you to add Canada, Mexico. Again, add the layer file. Get the red exclamation point, which means you have to change where it's located. Double click that. Notice in the data source under location, it's got some funky URL that is not where your data is, so you need to tell it where it is. To do that, you hit the set data source. Again, look in data. You want to tell it where that shape file is. Remember, the shape file, the layer file uses the shape file. And now it's in the right spot. Click OK. So I've added states in Canada, Mexico, which is what it looks like on page 175, step 3. Step 4, add lakes.layer to the mainland states. So lakes.layer. Oh, that one didn't have a red exclamation. It should be placed above all the layers. So that's good. That did go in the top. Step 5, add lat long dot layer.
The layer or the shape?
The layer, everything should be adding the layer.
Oh.
Got the red exclamation point.
For that one, then you just got to double click it and tell it where it is.
I've been clicking on the shape for most of these and it's still coming up properly.
You're getting the shape, but you're not getting the correct colors. You shouldn't be getting this. Like the green, no, it knows it should be this shade of green. It knows that it should be 0.9 to 4.5. It'll come in.
Yeah, it's there.
Oh, you should be doing the layer.
Okay.
That's a
For
5.
that long, it gave me a red exclamation point. Did it for you?
No.
Okay.
So
That's
just
the first one I did layer on, so I don't know. I'm gonna fix it.
so just double click it and point to where it is. You're pointing to the shape file, not the layer file.
So I right clicked and went to properties for lat long. It's source, set data source,
Source, set data source, yeah.
and then the shape file for lat long.
Yes.
And, okay. Now the exclamation point is gone. That's fine.
Okay. Then the next step is to take that lat long and drag it to the bottom. Drag it below all the other layers in the mainland states data frame. And use the measure, we're not going to use the measure tool to measure distance between 2 lines of latitude and 2 lines of longitude. Step 6, add cities.shape. Now this one isn't asking for the layer file. So we're going to add, oh, because there isn't a layer file. Cities.shape, and now cities comes in. Oh, I didn't get a warning. Did anyone get a warning? Just hit close. Oh, tip, if you don't see the warning, it's likely you select the don't warn me again ever. Which, yeah, I bet I did that. When you see that error message on page 177, just click close for the rest of this class. It doesn't mean anything. So step 8, in the table of content, oops. The table of contents, double click cities, which opens up the layer properties box. You could also right click and go to properties of thousands of geoprocessing tools. Just click that once. And if your computer is crap, it will crash right about now.
Oh,
Hey. So there's all the different tools in Arc Toolbox. These are the different things that you can do to your data. Way more than you ever need to know. Okay, so that's step 10. Step 11 in the Arc Toolbox window, expand data management. Go to projections. Everything's in alphabetical order. Projections and transformation. And they want you to use the project tool. So we're going to double click that. And yes, it takes a little while. Oh, and mine over here. Lovely. Okay. All right, so page 179 is what the tool looks like. You need to fill in the various items to get the tool to work. Notice there's green circles. Green circles are good. Red is bad. So we'll just go through the list. Click the input data set. And we want to select cities. So notice the green went away. We have cities. Click the browse button next to output. And the browse button is just the folder button. And browse to the My Data folder. My Data folder, chapter 6, My Data folder. In the name box, type cities, GCS, NAD 1983.shp. And you have to type it in exactly like that. And click Save. So we're going to take the cities layer. It's got a projection of WGS84. We're going to create a new shapefile called cities GCS NAD83. So we're going to change the coordinate system from WGS84 to NAD83. And save. Then for the output coordinate system, put the box next to it. Now we're going to pick a coordinate system. This is step 15 in the browse panel. Expand the geographic. So there's geographic and projected. And we want to find North America. Scroll down to NAD83. And there is a difference between NAD83 2011, CORS 96, CSRS, NSRS 2007, 1983 HARN. When they say NAD83, just do NAD83. Don't select anything else. If it tells you to do NAD83 2011, don't select just NAD83. This is where you're going to get into problems if you select the wrong coordinate system. So NAD83. That was page 181. Then click OK to close the spatial reference. Okay, now when I click this, you want to see in the bottom right a green check mark. Half of you probably won't see the green check mark, but we'll see if mine works.
Sorry, in the spatial reference properties, step 14.
Green check mark. Step 14,
Yeah.
yes.
What are we doing there?
You're gonna hit the plus next to geographic coordinate, you're gonna follow step 15, hit the plus next to geographic coordinate system, hit the plus next to North American, scroll down, you'll see NAD 83 is one of the options, then just select that.
All right.
Yep.
On 13 here, we had to just type this long thing in and then click save.
Yes, you had to type in cities, GCS, NAD 83, very important, put in .shp.
And then capitals and stuff.
It doesn't matter.
Okay.
All right, so I did, clicked OK. Steps, I'm up to on page 183, step 17. After you go through it, you click OK. The bottom right, you'll see the green check mark.
Bottom right, I got an X.
That means that you probably don't have read-write permission to wherever you save that file. Did you put it on your desktop?
Yeah, I think I chose the my data. I chose my data, but it wasn't the desktop one. I
That's
think it was-
that's why you got
yeah.
the.
Okay,
Yeah, if
so-
you chose the S drive, it doesn't allow you to save anything.
all right.
If you chose something on the C drive, it doesn't allow you. That's why all the data goes on the desktop.
Okay.
It eliminates that problem. All right, step 18, close Arc Toolbox. And the table of contents, right-click cities. Also notice that now there's that cities GCS NAD 83 is now in your table. So they want you to first remove cities. So right-click, table of contents, right-click cities, and click remove. Okay, remove the right one. Page 184, step 19. Table of contents, double-click mainland states data frame. Double-click that. On the coordinate system tab, so there's a bunch of tabs, there's coordinate system. Expand the projected, so the geographic, we're going to expand projected. Continental, yeah.
I've redone everything twice, and each time I open the project tool, it crashes the program.
It's crashed. Okay, you open up the MXD, you go to Arc Toolbox, you double.
Well, I redo all the data on the table of contents thing,
Uh,
and then I open the toolbox and get to the point where I want, and it does that. Raise everything up, and
that means that computer stinks. That, unfortunately, that is the correct answer. If that were to happen to me, I would, number one, reboot my machine and start all over again. Unfortunately, that's what you have to typically do, because it shouldn't do that. Something happened on the computer. You could try closing down ArcMap. I would, yeah, before you close everything down, close ArcMap and try that again. So close down ArcMap, open up the MXD, and then try to do that. If that, then you have, the next step is rebooting the entire machine. All right, continuing on. Page 184, step 19. Table of contents. Double click the mainland, we did that. Go to the coordinate system tab, go to projected coordinate system, go to continental, go to North America. So we're going to give this the USA contiguous Albers equal area conic. USA contiguous Albers. Yeah, spend some time and just look at all the different projections that there are. And everybody uses different ones. That's why it'd be nice if everyone used NAD 83, but they don't. So select that. And click OK. So now we've changed the XY of the orange to this contiguous Albers equal area conic. Not realistic for anyone. Maybe some scientist somewhere wants to use it like that. Step 21, bookmarks. On the menu bar, click bookmarks, mainland states. So now it zooms into the US. And step 22, in the table of contents, hold down the control key.
For step 20.
Yeah.
Are we clicking the adding activity even though it says something different in the book?
No, you're going. What you're doing is you're going to the. You're getting rid of cities. Then you're going to double click this new one. And coordinate system tab. Oh, the main ones. Oh, you're doing the data frame. You're not doing cities. So double click the data frame, go to coordinate system, and then you're going to select, you're going to make the coordinate system of that entire frame USA contiguous Albers equal area conic. And to do that, you're going to drill down, which I hate saying, projected, continental, North America, and then you make your way down to this USA contiguous Albers. Then you're just going to select that. And when you do that, you get a funky looking USA. Then you go to the bookmark, and the bookmark will push you right to where you're supposed to go, which is this. All right, so step 22, table of contents, hold down the control key. Click cities, US states, Canada, Mexico, to select them. Right click any, oh, okay, so what we're gonna do is we're gonna take these 3 layers, we're gonna copy them into a different data frame, either Alaska or Hawaii. So we right click, copy, and we're gonna put this in the Alaska frame. So we click Alaska, right click, paste. And I'll do that again. They want us to select cities. And to do this, you hold down the control key, cities, Mexico, US states. Then any one of these blue, you right click, hit copy. Go up to Alaska, right click, and hit paste layer. Notice that it will now go into that Alaska data frame. Step 23 in the Alaska data frame, hold down, control and click Canada, Mexico to remove it from the selected layer. Okay. We add it, we remove it. Then right click either of the 2 selected layers and click copy. Either one. All right, I'll take that one. Then go down to Hawaii and right click and paste. So now I put the US states layer in Hawaii.
Quick question.
Yeah.
On 20 for the US contiguous,
Yep.
whatever, it's under the projected in North America. I don't see it as North America something. Yeah, oh, found it. Thanks.
You double click it, go to coordinate system,
Projected.
go to projected, go to continental,
Mm-hmm.
America, scroll down, and it's there.
Yeah, I didn't have that. I mean, it looks like that. It was,
click
just
the
called,
book.
it was just called United States instead of continuous, same thing, but
instead of North America, it was called United States.
It was like, yeah, United States.
I don't, just,
I'll show you.
yeah,
North
just,
America, Albert's equal area.
Yeah.
Continuous.
Just, yeah.
That's fine.
okay.
It looks the same.
No, I'm still in step 23. And then remove it, right click, to selected, click copy, finally right click the Hawaii data frame, click paste. So they want us to move both. That's fine. Cities, right click, copy, Hawaii, right click, paste. So now both Hawaii and Alaska have cities and states. That's step 23. Step Okay, the image on page 186 for Alaska actually shows Canada, Mexico on there. They told me to remove it. Yeah. That's fine. Step 24, table of contents, double click Hawaii. The coordinate system tab, so we go to the coordinate system tab, expand projected. So there's the projected. Go to continental. North America, it should not say United States, but if it North America. Now we want to change this one to Hawaii. Everything's in alphabetical order, so you don't have to go too far. It's the fourth one down. And click OK. So now notice that it changed in the Hawaii frame. Step 25, I'm on page 188. Activate the Hawaii data frame. So to activate the frames, it'll be in a bold. So right now, mainland states is bold. So they want you to make Hawaii bold. Right click, activate. So now if you, Hawaii is now bold. Bookmark Hawaii. So that brings in where Hawaii is located. So we're probably gonna do the same thing for Alaska. And that's what it says. Repeat the same steps. All right, so we need to first double click on Alaska, give it the projection of Alaska Albers equal area conic. Double click, coordinate system, projected. Oops, there was geographic. North America, and I picked the wrong one.
So we're pretty much doing the same for both Hawaii and Alaska.
Yes,
Same
exact same thing.
Okay.
It should be in projected.
Well, you don't want to copy Mexico.
No, you it said to on there.
It says to remove it from the selected layers.
On 23.
Follow the instructions. You're not going to lose any points if you have it there or not.
Okay.
Bookmark, Alaska. I didn't do it right, so I need to change that. Properties. Should be under projected. Continental, that's what I was missing. Now it's Alaska. So now it brings it in. Okay. So now you have Alaska in that one, Hawaii in that one. Okay, so you're going to take a screenshot of this, which is step 26.
We have
And
to have that little Alaska thing up in the corners.
Yeah. And then you're doing that exactly like Hawaii, even though it doesn't give you the exact instructions. So do exactly what you did here. You have to change the Hawaii or the Alaska data frame first. So change that to that Alaska Albers conic, whatever it's supposed to be. Then hit the bookmark, and it will take you right to Alaska.
I don't have it on that. I've got like a world map here. Oh, no, yeah, I've got the Alaska. When I'm putting this.
Double click Alaska.
Yeah.
Okay, click OK. Okay, go to bookmark. Okay, yeah, okay. Right click Alaska. Activate. Now go to bookmark. Alaska.
Okay, same thing with this.
Same thing with that.
Cool.
If you go quick on C. Okay. So I'm looking for that as a screenshot and then submit your MXD. All right, I got 15 minutes to do 6C.
It didn't work for that. Oh,
Remember, you have to activate it.
yeah, and it's like, it's doing it, but then it's not doing it.
Okay, defining a map projection, which is 6C, so we need to open up the 6C MXD. And page 191 looks like what it looks like up there. And step 1, step 2. We're going to add Colorado counties from your data folder to the state plane data frame. Yeah.
I'm catching up from when I had to reboot the computer and I got the red X after I did the project. Red X in the lower corner. Instead of green check mark.
The lower corner.
Like, it showed up at the bottom right hand corner of the screen. The
Um,
bar that says project with the hammer next to it, and it does have a green check mark that had a red X.
Let me get through 6C and then I'll come and help you. All right. Add Colorado counties. When you're adding data is always the plus button. Chapter 6, data, Colorado counties, shapefile, click add, unknown,
Yeah, what do you want here? Just okay.
just click OK.
Alright.
Click OK to close the error message. Step 4, right click the Colorado counties layer, click zoom to layer. It's now actually moved it out to California. I want you to zoom out. You zoom out a little bit, you can see that it's there. So that means the projection isn't the right one, so we're going to change that. So step 5, on the standard toolbar, click our toolbox. Step 6, data management, projections, and transformation, exactly what we did last time. Now we're going to, instead of using the project, we're going to use define projection. Which is the one above project. And there's only 2 things in this one. So step 7, the input. It's going to be Colorado counties. When you do that, it knows that it is not in any known coordinate system, so we're going to give it a coordinate system. And step 8, click the properties box next to coordinate system. Step 9 in the spatial reference property, which is over here. Expand projected, continental, North America. We're going to give this one USA contiguous, Albers area conic. Click OK. It's 186 step 10. Yep. Click OK. And we get the red X or the green check mark, which means everything's good. So now notice that it's no longer in California. If I right click zoom, it has now been projected to actually Colorado.
It's really cool.
It becomes a big headache later on, but to do that is pretty neat, yeah. All right, so they're telling you to do the bookmarks. Bookmark to Colorado State, the same thing. If I right click and hit zoom to layer, it brought me right to it. So that was step 12. Oh, step 13, in the table of contents, drag the Colorado counties layer to the UTM.
Real brief
briefly?
Yeah.
For 6B, we need a hidden MXD,
6B, yes, screenshot MXD,
just the screenshot of that.
screenshot and MXD.
Oh, and MXD?
Yep.
Okay.
And it's gonna be the same thing for 6C. You're going to get this screenshot MXD.
Okay.
So actually, I'd do that.
And that's around step 13?
It is step 13.
Okay.
So you've done step 12, it brings it in here, then they want you to copy that to the UTM and paste it in. Since it knows what the projection is, before it wasn't projected, so it went to California. Since we gave it a projection, it automatically put it in, it projected on the fly. Because this box right here is in this UTM coordinate system zone 13. This box is under state plane coordinate system Colorado. In the beginning, it didn't have a coordinate system. When we gave it a coordinate system, it knew it enough to change that for you, so you didn't have to do that, which makes your life so much easier.